Good evening, children. So after remainder theorem, we are going to discuss another very important theorem, and it is factor theorem. Generally, remainder theorem and factor theorem both are closely related to each other. Okay. So here again, I am not going to prove this factor theorem. Okay. I will simply read it out for you, and later with the help of example we will try to understand this factor theorem, and both the theorems are very important for exam point of view. Okay. So here I am going to read it out. Okay. So what factor theorem says? So this theorem says if p of x, so p of x means any polynomial in terms of x. If p of x is any polynomial of degree greater or equal to 1, and what should be the degree of this polynomial p of x? The degree of this polynomial should be either equal to 1 or more than 1. So what do you mean by equal to 1 or more than 1? Equal to 1 or more than 1 means it may be a linear equation like 2x plus 3, okay, 3x minus 7 like this, or 2x square plus 3x plus 7. It may be linear equation, it may be quadratic equation, it may be cubic equation 3x cube plus 4x square minus 7x plus 19 like this. Okay, it may be quadratic equation and equation of order 4. Getting this or not? Okay, so p of x is any polynomial of degree greater or equal to 1. Okay, and a is any real number, where a is any real number. Okay, now after that we have two statement. Okay, so first statement is x minus a will be factor of p of x if p of a is equal to 0. You pay attention again, we have given any polynomial p of x, okay, and the degree of this polynomial p of x is either 1 or more than 1, okay, and a is any real number. So in that case our first point is x minus a will be factor of p of x. So x minus a means any linear equation, okay, any linear equation x minus a will be factor of p of x if p of a is equal to 0. And what is the meaning of p of a? P of a means in this polynomial p of x, in place of x we are going to substitute a. This x we are going to substitute by a, or in place of x we will put a. Getting this or not? Okay, again I am going to repeat it. Okay, if x minus a will be factor of p of x, this linear equation x minus a will be factor of p of x given polynomial if p of a is equal to 0. It means in this polynomial in place of x we are going to substitute a, and after substituting a, if the value of equation will be 0, so in that case x minus a will be factor of this polynomial. Okay, and second step, p of a will be 0. P of a will be 0 if x minus a is factor of p of x. Getting this or not? P of a, it means in given polynomial in place of x we will substitute a, and that will become 0 when if x minus a, it means that linear polynomial will be factor of given polynomial. Okay, it is not easy to understand. Perhaps you will be not getting this. You will be totally confused after hearing this theorem. Okay, after reading this theorem. Okay, getting this or not? So this is the reason that I am telling you, with the help of example we will try to understand it. Okay, children. Okay, children, may I ask you how this factor theorem is related to the remainder theorem? Children, you see here what we are doing here. If we are dividing this polynomial p of x by another linear polynomial x minus a, so if we have to find remainder, what we will do? To find the remainder while dividing this polynomial by this polynomial, what we will do? First we will find the 0 of this polynomial. And what will be the 0 of this polynomial? The 0 of this polynomial will be, we will equate x minus a, we will put this x minus a equal to 0, and from there x is equal to a. So it means in given polynomial we will substitute x is equal to a, okay, and we will find the remainder. So what is happening in that case? After substituting x is equal to a, if a remainder is 0, p of a 0 means if a remainder is 0, so it means x minus a will be factor of given polynomial. Getting this or not? Okay, similarly here it is happening if x minus a is factor of p of x. Getting this or not? This divisor is factor of dividend, so remainder will be 0. Getting this or not? So p of a means remainder will be 0. So let us try to understand this with the help of example. Getting this or not? Let's suppose we have any polynomial 3x square plus 4x plus 5, let's suppose. Okay, and we are dividing this polynomial by x minus 2. Getting this or not? We are dividing this and we have to find remainder. So for remainder, what we will do, first we will find the 0 of this polynomial. Okay, so we will put x minus 2 is equal to 0. Okay, from here x is equal to 2. So now this x is equal to 2, we are going to substitute in this polynomial, in this p of x, where p of x is equal to 3x square plus 4x plus 5. In this p of x, we are going to substitute x equal to 2. So p of 2 we will find. So after substituting x is equal to 2 in this polynomial, if our remainder, if the value of this polynomial is 0, so it means in that case this will be factor of this another polynomial. Getting this or not? After substituting x is equal to 2, if the value of this complete polynomial is equal to 0, it means p of 2 is 0. If p of 2 is 0, so what will happen in that case, x minus 2 will be factor of this number. Getting this or not? Okay, otherwise if p of 2 is not equal to 0, if p of 2 is not equal to 0, so in that case x minus 2 will not be factor of this given polynomial. Okay, so let us try to understand with the help of another example. If children, if I am asking you, tell me whether 4 is a factor of 24. You have to tell me whether 4 is a factor of 24. So for that, what you will do, you will divide this 24 by 4. Okay, how many times 4 can divide 24? 4 7 ja 4 6 ja 4 6 ja 24. Okay, remainder will be 0. Getting this or not? So this 4 is dividing 24 completely, 6 times it is dividing. Our remainder is 0, so we can say yes, 4 is factor of 24. In similar manner, if I am asking, you have to find whether 3 is a factor of 36. Whether 3 is a factor of 36. So what you will do to find whether 3 is factor of 36? You will divide this 36 by 3. So you will find how many times? 3 1s 3. Okay, 0 6. 3 2 ja 6. Again remainder 0. Now our remainder is 0. So we can say yes, 3 is factor of 2. Okay. In the similar manner, if I am saying whether 5 is a factor of 22. Whether 5 is a factor of 22. So to find whether 5 is factor of 22, what you will do? You will divide this 22 by 5 and you will find remainder. If a remainder is 0, we will say yes, 5 is factor of 22. And if a remainder is not 0, we will say no, 5 is not factor of 22. So 5 4 ja 20, your remainder is 2. So remainder is 2 in this case. Our remainder is not 0. So it means 5 is not a factor of 22 because 5 is not dividing 22 completely. Our remainder is not 0 here. So in the same manner, if after dividing this by this one, okay, or using remainder theorem, if our remainder, using remainder theorem, if our remainder is 0, so we will say yes, this is factor, and if our remainder is not 0, we will say this is not a 0 of given polynomial. Is this clear? Okay children, so now we will take example. So here we have to find if x plus 1 is factor of x cube plus x square plus x plus 1. Okay children, we have to find whether this x plus 1 is factor of this. Getting this or not? So for that, what we will do? Okay, so what I said, we will try to find the remainder. Okay, so we will try to find the remainder. It means after dividing this polynomial by this linear polynomial, if remainder is 0, we will say yes, this is factor of this given polynomial. And if remainder is not 0, we will say no, this is not a factor of given polynomial. Getting this or not? And to find the remainder, how many methods we have? We have two methods. One is long division method. So first we will use long division method. So x plus 1, this is our divisor, x cube plus x square plus x plus 1, this is our dividend. So first quotient of first term of our dividend, for that what we will do? Okay, we will divide this first term of our quotient x cube by first term of our divisor. So as you will solve this, it will come x square. So x square is first term of our quotient. So now this x square you are multiplying with this divisor and you will write product here. So x square into x cube, x square into 1 plus x square. Subtract this polynomial by another polynomial, so sign will change. It was positive, so now it is negative, and earlier it was positive, again it will negative. So minus plus x cube minus x cube cancel, plus x square minus x square cancel. Now what is remaining? X plus 1. Getting this or not? Again you see the degree of our remainder and the degree of our divisor both are equal. We will solve it further. So now we have to find second term of our quotient. So for second term of our quotient, what we will do? We will divide this first term of our remainder by first term of our divisor. So x upon x, it will become 1. So 1 is our another term of second term of our quotient. So now this one you will multiply this and will write product here. So x into 1 x and 1 into 1 1. So now you subtract, again earlier sign was positive, now negative, and again sign will change minus. So x plus 1 and minus x minus 1 both will cancel, plus x to minus x plus 1 to minus 1, remainder will become 0. So in this case we will say yes, this x plus 1 is factor of this. Getting this or not? So one method is this, but every time we cannot do this. Okay, so for that what we are going to do? We are going to use factor theorem. So for factor theorem, what you will do? So for factor theorem, let p of x is equal to x cube plus x square plus x plus 1. Okay, and we have linear polynomial x minus a. Okay, we have to find its 0. So 0 of x minus a. So to find the 0 of x minus a, so x minus a is equal to 0, not x minus a. Linear polynomial is x plus 1. X plus 1 here. This is x plus 1, okay. So x plus 1. So from here x plus 1 is equal to 0, x is equal to minus 1. Okay, so x is equal to minus 1 we are going to substitute in this polynomial. So what we are going to, x in place of x minus 1, so substituting x is equal to minus 1 in p of x, so it will become p of minus 1. Okay, p of minus 1 is equal to, in place of x, minus 1 cube plus minus 1 square plus minus 1 and plus 1. Okay, so p of minus 1 is equal to minus 1 cube, it will become minus 1 cube minus 1, and minus 1 square, minus within bracket and power is even, so it will become plus 1, again minus 1 and plus 1. So minus 1 to plus 1 cancel, minus 1 to plus 1 cancel. So p of minus 1 is equal to 0. So you see here our p of minus 1 is equal to 0. So it means x plus 1 is factor of x cube plus x square plus x plus 1. Is this clear, children? Okay. So now perhaps it will be clear for you. Okay. We have given this polynomial. So here our polynomial x minus a is our x plus 1. Okay, and this another polynomial p of x, this p of x is x cube plus x square plus x plus 1. This is our p of x. Getting this or not, children? This is our p of x and this is our x minus a, and we have to find. Okay, so what is happening here? We have to find whether this is whether x minus 1 is factor of this one. So for that what will happen? First case, okay, if x minus 1, if x minus a, it means x minus 1 is a factor of p of x. It means if x minus 1 is factor of this polynomial, then what will happen? P of a, it means the 0 of this polynomial or 0 of this x minus a. So 0 of this x minus a is minus 1. So in this case what will happen? P of minus 1 should be equal to 0. If p of a is equal to 0, yes, x minus 1, x minus a will be factor of p of x. So same thing is happening. Okay, if p of minus 1 is equal to 0, so we will say that x minus 1, x plus 1 is factor of given polynomial. Okay, so with the help of another example we will try to understand it. Here we have another example. We have to find if x plus 2 is factor of 2x plus 4. Easy example I am taking, okay? So easy example I am taking. So we have to find whether x plus 2 is factor of this polynomial. Getting this or not? So what will happen? Let p of x is equal to 2x plus 4, okay, and linear polynomial is x plus 2, okay, and we have to find whether this is factor of this one. So for that, what we will do, first we will find the 0 of this polynomial, okay, and to find the 0 of this polynomial, x plus 2 we will keep equal to 0. From here x is equal to minus 2. So now what we are going to do, substituting x is equal to minus 2 in p of x. So in this p of x we are going to substitute x is equal to minus 2. So substitute. So p of minus 2 is equal to 2 in place of x minus 2 plus 4. So 2 into minus 2 minus 4 plus 4. So p of minus 2 is equal to this one. P of minus 2 is equal to minus 4 plus 4, 0. Getting this or not? So p of minus 2 is equal to 0. So here we will say yes, x plus 2 is factor of 2x plus 4. Okay. Another more example I am taking. Okay. Here we have to find if x plus 1 is factor of 2x square plus x plus 9. Okay, we have to find if x plus 1 is factor of this polynomial. So briefly, quickly I am going to solve this. Okay, I will not take much time. So what we are going to do, first p of x, let p of x is equal to 2x square plus x plus 9. Okay, and our linear polynomial is x plus 1. We have to find the 0 of this polynomial. Okay, so 0 of x plus 1 is equal to 0. You equate it equal to you keep x plus 1 is equal to 0. From here x is equal to minus 1. And now in this polynomial p of x we are substituting x is equal to minus 1. Substituting x is equal to minus 1 in p of x. So substitute p of minus 1 is equal to 2 in place of x minus 1 whole square plus in place of x minus 1 plus 9 will be as it is. So p of minus 1, so 2 minus 1 square 1. Okay, so minus 1 square again 1. So 2 I am writing as it is. I am not writing 2 into 1. Okay, and again here you see okay, so okay children, okay, so 2 into minus 1 square, so minus 1 square 1, so 2 into 1 2, and plus into minus 1 plus 9. You solve it. P of minus 1 is equal to, so 9 plus 2 11, and 11 minus 1 10. So here you see p of minus 1 is equal to 10. This is not equal to 0. So p of 1 is equal to, it means if you are dividing this polynomial by this polynomial, so remainder is non-zero, remainder is not 0. So we can say that x plus 1 is not a factor of 2x square plus x plus 9. So perhaps children you understand it. You watch this video repeatedly and again if any doubt you please message me. Okay.